Okay, here we go. Hello, everyone. This is Sachin Patel, and today I have a very special guest, a dear friend and colleague of mine. I have Dr. Sab Virani. Today, we're going to be discussing really an earth-shattering, paradigm-shifting concept that if you follow through with this, by the end of this presentation, you will be absolutely convinced that we have a broken medical system because it uses the wrong mathematics. Now, for those of you that are thinking about algebra and geometry and calculus, I hope this doesn't bring you back to those horrible moments of high school and maybe even college. We're going to show you the beauty of math. We're going to show you a whole different paradigm of math that you never learned about in school, and math that's super exciting and essentially weaves itself throughout every single scale in the entire cosmos. So with that being said, welcome, Dr. Virani. Thanks for sharing this beautiful work with us. And I know you've poured a lot of time, energy, and effort into putting this presentation together, as well as your book. And you're on a mission to get this message out to as many people as possible so that not only can you mathematically validate that functional medicine works, but you have unequivocal evidence that this is the right way for us to move our entire healthcare paradigm. So welcome to this awesome little jam session that we're going to have today.
Well, thank you so much, Sachin. As Sachin described, the title of this talk is The Paradigm-Shattering Science of Fractals, Why Fractal Math Proves that Functional Medicine is Infinitely Superior to Conventional Treatment. There we go. So who am I? So as Sachin said, my name is Dr. Sab Virani. I'm a psychiatry resident at the University of Toronto, and I'm also a functional medicine practitioner in training who's in the Living Proof Mentorship Program. And I just wanted to say another really big thank you to Sachin and the Living Proof Institute for encouraging me to kind of share this information. I can't thank you enough, so just wanted to say thanks again. All right, so let's get started. The objectives of today's talk are as follows. So firstly, I'm going to share my story, which is how I discovered fractals and how fractals helped me discover functional medicine. I have a little bit of a disclaimer. And then we're going to talk about conventional medicine's outdated mathematical toolbox, which might be familiar to some of you guys. And then we'll move into the meat of the talk, which is the mysterious science of fractals, as well as how to apply this fractal wisdom to health and healing. Okay, so my story. So like many of you guys out there, I found functional medicine because I got sick too. So in my first year of medical school, I got really sick. I did the conventional treatment, but I really continued to worsen. I got even sicker in residency, and in 2014, I was completely forced to stop working, and I ended up on 30 or more pills a day. It was really a really awful time in my life. So I was pretty desperate, and I had nothing better to do, so I did what most people do. They turned to the internet for solutions, and I put 2 words into Google. I put autoimmune and cure, and I pressed enter. And lo and behold, I found the Institute for Functional Medicine. And I was always the kind of person that really needed proof. Like I was, I always needed to see the research study to really know if something was true or not. But I had nothing else to lose, so I took their free e-course that was available at the time. I'm not sure if the same one is available today. And in that e-course, I learned that functional medicine is actually based on the science of systems biology. And systems biology is really based on the science of what are known as complex systems. So what are complex systems? Well, in math and science, there's actually 2 types of systems. I never even knew that this existed. So there's complicated systems, and complicated systems can be easily solved by a computer. So it would be something like, sending 1 million emails to your email list or something difficult. Like one person couldn't do it, a computer could do it, but it's easily solvable by a computer. On the other hand, a complex system is something that's completely different. So it's made up of, it's a system that's made up of multiple different parts that when they act together, they actually produce something that's more than the sum of their parts. So a computer is not able to solve complex systems. So an example of a complex system would be if you add sunlight, soil, oxygen, seeds, and I forgot water, but you would get plants growing out of almost nothing, right? You can't add these things together and get this in a traditional sense. We add these parts together and something grows that's beyond the sum of the parts. So that's what a complex system is. And the human body is also a type of complex system. But when I saw that, I was 100% convinced, even without a randomized controlled trial, that functional medicine was going to save my life. And that's because I had a secret weapon. I was an ex-math teacher. And when I was a math teacher before medical school, I actually learned about fractals from a colleague of mine. And I learned that fractals were the math behind complex systems, and also the math of both biology and nature. So basically the math of the universe, the patterns of the universe. So in that moment, I immediately realized conventional medicine is using the wrong math, and functional medicine is using the right math, which of course is fractals. All right. So I'm going to just give a little bit of a disclaimer and just a bit of a warning. So fractals, what I'm going to teach you about fractals is really different than anything you've ever learned about math before. It's a really, really big paradigm shift, maybe almost even on the level of discovering that the Earth goes around the sun. So just try to keep an open mind. Some of these concepts are really difficult for me to get at first, but the good thing about fractals is that because the universe is essentially full of fractal patterns, they're very familiar to us. So we don't really need to understand their properties using numbers or any calculations or anything like that. We can just look at images and then start to kind of understand the patterns. So hopefully that helps some of you guys who might be a little bit worried. Oh my God, there's going to be math. I'm not sure if I'm going to understand it. So hopefully that will feel a little bit better. There are also animations in this talk. So if for whatever reason you feel like you might get dizzy, just to let you know, you can look away or close your eyes. All right. So now we're going to move towards talking about conventional medicine's outdated toolbox, because before we get into fractals, we sort of need to understand a little bit more about the tools that we're using right now. So what math are we actually using in conventional medicine? So I have a little bit of a pretest. Hopefully it's not going to be too difficult for you guys, but here's the pretest. If you had to guess what kind of mathematical relationship this is, take a guess. Maybe Sachin can guess. Well, it's kind of a linear relationship. We would normally, think of this as a linear relationship, and we would analyze it as such, doing linear regression. Something like this, well, it looks kind of like a bell curve, right? Most of you guys are going to be familiar with that already. All right. And when we do research, normally what happens is we end up getting data, but the data doesn't really fit these nice, clean relationships that we always want to see. The data is always pretty messy. And that's because maybe there's, experimental error going on. It could be elements of random chance. It could be limitations of our tools, our measurement materials. But there's a big assumption that we've been making. And that assumption is that as our technology improves, that our precision, our ability to measure data is actually going to get better. What we end up doing is, in the end, we need to clean up the data. So we use conventional statistics in order to do that, in order to find the relationships inside the data that we've discovered. And so, of course, this is a bell curve. We can use averages or the mean. We can use things like variance, standard deviations, t-tests, p-values, and there's probably hundreds more different tests, but those are kind of the main ones. But where does this bell curve actually come from? If we actually sit and think about it, what's the origin of all of these tests? And it actually comes from coin toss experiments from 400 years ago. And if anyone remembers Statistics 101, the bell curve actually comes from something called the binomial distribution. And binomial distribution, bi means two outcomes, which are heads and tails. No, I kind of think of as number of trials. Me, I sort of think of as independent. So each time you flip a coin, it's not going to affect the second time you flip a coin. It's 50-50 probability either way. So independent trials, and all trials have equal probability. So, right, 50% heads or 50% tails. And so you would get a graph like this, and if you increase the number of trials, you start to get something like this. And you can start to see that the bell curve shape actually forms. And so the bell curve is actually the continuous distribution of this curve. So they just say, well, you know, as we keep adding trials, it's eventually going to become completely smooth. And that's how you form the bell curve. And the bell curve has pretty much become the language of science. You know, we need to use math in order to determine anything about any clinical trials. But there's definitely problems with using this type of math in order to find those types of answers. And that's because, is life really just about two outcomes? Is it, you know, are two things just equally probable in life? And are things that happen in life completely independent of each other? I think we all know that the answer to that is no. Are there any bell curves or straight lines found in nature? Anywhere, anywhere. Well, you might think, okay, my table has a straight line, but actually if you use a microscope, you'll see that the actual surface of your table, even if it feels smooth, it's not smooth, it's actually rough. So the answer to that question is also no. Is anything randomly distributed in the universe? You know, we all often compare things to an even distribution of things, but I don't see anywhere in the universe where things will just 100% evenly distribute. So that's a problem as well. And there's something not entirely random about things in our universe. If you look at this picture on the right, this is a picture, I believe it's from New Horizons. This is Pluto. And this is an ice formation. I'm not sure if it's methane, but it's been affectionately called the heart on the surface of Pluto. And I was on Wikipedia somehow, and I saw this image, and it was a frozen bubble of water. So this is super tiny. And it also kind of has a heart-shaped crystal formation on its surface. So patterns in the universe aren't really completely random. And there's even more problems with using this coin toss-based approach. Precise data seems like it's really impossible to find. If we take a look at the electroencephalogram, which is measuring electrical activity of billions and billions of ion channels in our brains, we get this super, super messy looking graph. And historically, other than seizure diagnosis, the EEG was always thought to be not very useful because nobody could figure out how to get rid of all this noise in the data, right? It's too noisy. We can't find the real signal. And you would think that if we boil it down to a single measurement with a single channel, that we would get a much cleaner data set. But unfortunately, we get pretty much the exact same thing as we get when we are trying to measure billions of ion channels. We still get messy electrical signals. So what's really happening here? So clean data is really a little bit impossible to get. And it's not due to error. You know, we've been making that assumption that it's been due to error and that we have to clean it up. But in actuality, it's because nature is fractal. And the data, the messy data itself, is also fractal. And so what does that really mean? Well, we'll get into it now. So we're going to talk about the very mysterious, very unusual science of fractals. All right. So, all right, in the 1970s, a man by the name of Benoit Mandelbrot, seen right here, he was working for IBM, and IBM had tasked him with to try and solve a puzzle they were having. They wanted to figure out how to transmit signals through phone lines, but they kept finding that there was all this noise, there was all this messy data like the EEG through those signals. So they asked Benoit Mandelbrot, who's a mathematician, help us clean up this data, help us get rid of all that noise. So he was experimenting. And while he was experimenting, he took a really, really simple equation, z squared plus c. And just to remind you guys, that equation, you know, if we graphed it normally like we would in high school, it would just be a simple parabola. So very, very simple. And what he did was he put this into a recursive algorithm. And for those that don't know what a recursive algorithm is, it's when you have a sequence where the first number is used to make the second number, which is used to make the third number, which is used to make the fourth number. And this is just an example of that as the Fibonacci sequence. So he took this simple parabolic equation and created a recursive algorithm and graphed it onto what's known as the complex plane, which is graphing complex numbers. Now, you don't really need to know what those are. It's kind of a little math-heavy thing. But needless to say, the algorithm was repeated millions of times through the aid of computers, because this was really the first time that they were able to do that. This was it could not be done by hand. So this had never been seen before. And this is what he discovered. Oops. There we go. So I'm just going to let it go for a little while. So just take it in. We see some kind of strange beetle shape, and the graph keeps changing and changing and changing. And then all of a sudden you're getting these crazy spirals and other crazy shapes. And so initially people actually thought this was an artifact. His colleagues thought he must have made a mistake. This must be something that the computer is doing. See, we see the same shape again coming back. But actually what he had discovered was an entire set which he called the Mandelbrot Set. And this is the most famous fractal. Okay, so what is happening with that? What is that? It turns out that he discovered a completely new type of geometry, which he called fractal geometry. And the essence of fractal geometry is that it is a simple algorithm that's repeated, that repeats millions and millions of times, and that creates this unimaginably complex shape. And it turns out that fractal geometry is actually the geometry of things that have roughness to them. So anything you can zoom in on in real life, you know, that if you use a microscope and you're going to see that it's rougher and rougher, that has a fractal geometry. And it's also the geometry of complex systems. So what really is fractal geometry versus, regular geometry? If we remind ourselves, regular geometry is really more about exact shapes. Like we have pyramids here, we know that pyramids have a certain dimensionality to them. If we zoom into the pyramid, they're going to have, smooth edges. Well, not the real pyramid, but, a pyramid shape when we're thinking about it in the geometry sense. Fractal geometry is completely different. It's dynamic. It keeps changing. Just like this graph here, you can see that it keeps changing and changing and changing. And yet there's some repetitive nature to the patterns. So let's take a look at some examples of fractal geometry. So here we have a bifurcating geometry. Looks like it's kind of making a tree or making flowers. So the shapes of fractals can look quite different. Here's another example of a fractal. You can see all these different spirals and spirals. So the shapes are not exactly defined as in the regular geometry. This is actually a picture, not of a tree, but this is actually a fractal drawing. This is just a still image, but if we could zoom in and out, you would see it branching more and more and more and more. And this is another still image of a fractal, and I really like this image because when I first saw it, it reminded me of the cross-section of the gut or the cross-section of a gland in the body. This is a fractal dodecahedron, and as it goes through more iterations, it gets more and more complex looking, and it starts to seem like it's having a little bit of organic qualities here and there. And when I saw this for the first time, I was like, oh my God, this looks really organic. That's a very strange shape. And it turns out that this is actually the Mandelbulb. It's essentially the 3D version of the Mandelbrot set. And you can see here that, you know, there's 1, 2, 3, 4, 5, 6, 7 or 6 around that make up the Mandelbrot. And once it becomes kind of 3D, it starts to really start having this more organic quality to it. And we can actually look at a fractal zoom video of the Mandelbrot. Let me just play it here. And you can see here that we can see these little bulbs, and then there's even more tiny little bulbs on them, and we can keep zooming in, and the pattern keeps repeating and repeating, and it just keeps going and going, and you can keep zooming in further and further. And when I saw this for the first time, I immediately thought of the shape of the alveoli, because the alveoli are these branched pockets of the alveoli in the lungs. So what's really going on here? What did Mandelbrot really discover? He discovered nature's geometry. And this is actually the secret that animators have been using to really go from animation that's, you know, like this, very simple, hand-drawn, flat, to something that's more realistic like this. So the programs that they use to animate actually have this kind of complex math built into the program to allow them to create something that's really realistic in terms of the look, in terms of the movement. And so now we're going to talk about the fractal properties. There's 6 main fractal properties. And the reason the properties are so important is because fractal shapes keep changing. And so we can't really define them the way we would define regular geometry, because regular geometry would be triangles, circles, but the shapes are dynamic with fractals. So we need to start to understand them in a completely different way. So the first property, and the most easiest property to understand, is fractal self-similarity. So this is another version of the Mandelbrot set. It's just colored a little bit differently to, you know, people like to color them in different ways. But you can see that that sort of beetle shape just keeps emerging again and again and again, and you can just see that same shape over and over. And so that's what it means, self-similar. It's sort of a repeating pattern. It repeats, but not identically, and at different levels of scale. So if we zoom in or if we zoom out, we're going to see that same pattern. So let's apply this to some examples. All right, I don't know if anybody's had a chance to eat this, but this is a Romanesque cauliflower. It's the cousin of a cauliflower. And you can see here that the Romanesque cauliflower, if we look at the shape of the large one, the same shape is echoed in these little small bulbs. And if we kept zooming in, we would see that same shape echoed in the even smaller and smaller bulbs. Just like this. All right. Trees also have a self-similar shape. If you cut off a branch of the tree, it looks like the big tree. So that same pattern is echoed over and over and over again. A fern leaf is really the same way as well. So it's extremely mathematically precise. So this giant fern leaf, if we look here, it's the same shape. And if we look at one of these little ones, it also has that exact same shape with the central stem and all these little parts coming off of it. So the same shape echoing over and over and over. Jagged edges also have this same pattern. So if you kind of zoom into the edge of a mountain, you'll see more jagged edges and more jagged edges and more jagged edges. Smoke and clouds, you know, the small part of the cloud kind of looks like the big cloud. Branching patterns are also fractal. So we have, these are blood vessels, this is a neuron, and this is the distribution of dark matter in the universe. So we see branching patterns repeat at different scales in the universe, so different sizes. Spirals, you guys might be familiar with the Fibonacci spirals, are found all over the place in nature, and it's because of the fractal geometry that it's found at multiple scales. And we already saw this from before. And this one was really interesting that I saw. This is a picture of a white blood cell, and this is a picture of a supernova. So really, like, all shapes at all scales repeat. Seasons also have a self-similar cycle. So fall comes every year, but it's not identical. So we can apply that concept to time as well. And our offspring, we can think of this as a self-similar, generation of offspring. And this is a picture of my grandma that I found. Looks exactly like my twin sister. And I was so shocked when I found this. Even the hair is similar. So patterns just repeating completely all over the place. And evolution also has this self-similar nature, the same body shapes kind of repeating in slightly different ways. Even on a smaller scale, our hormones are released in the same kind of cyclical way. And we have self-similar cycles of illness, self-similar cycles of wellness. People find themselves in the same relationships, falling in love with the same types of people, having the same kinds of fights, history repeating itself. So we can really apply this idea, this mathematical pattern, to a lot of things in our day-to-day lives. Self-similar cycles of abuse. A mean parent might have a mean kid. So it's actually a really powerful concept to apply. Our thoughts are also self-similar. Like, I always have the same dumb thoughts all over the place, just keep repeating. So thoughts are also self-similar. So essentially your life is like your own fractal Zoom video, like the Mandelbrot Set. So the take home from all of that is that nature has patterns that repeat. And I think we all kind of know that, just very intuitively. The second property of fractals is that they have infinite properties. And this was something that was super difficult for me to wrap my head around. And that's because for any fractal, you can keep zooming in almost infinitely and keep getting more and more and more complexity. So how does the body have infinite properties? I mean, like, I'm just sitting here, I'm clearly just one person. So how can my body really have these infinite properties? Well, if we zoom out, we can see organ systems. And if we keep going, we can see organs. We zoom in even further, we see tissues. We keep zooming in, we see groups of cells. We keep zooming in, we see single cells. If we keep zooming into the body, we're going to see organelles. If we keep zooming in, we're going to go down to the level of molecules. And these are actual photographs of actual molecules. And you can see that there's still a geometry there. There's still this kind of shape there. But also there's a roughness there. If we had the technology, we could even go further to maybe even see the structure of atoms, subatomic particles, subatomic particles. And so we need to kind of think of infinity in a slightly new way. I would always think of it in terms of like a great distance, like the edge of the galaxy. But really, infinity can actually occur in a very small space. So that was something that I thought was really, really fascinating about this new type of geometry. So the take-home message is that your body is really as infinitely complex as the universe itself. I mean, it sounds really, really bizarre. It sounds crazy, but that seems to be what fractal geometry is really telling us. So the next property of fractals is that because of this infinite property, it's creating a big problem. Our measurements are completely relative now. So what do I mean by that? So this is a picture of a fractal drawing of water droplets. And you can see here, I just put some arrows to kind of measure the size of these two droplets. So if we zoom in, the size actually changes. So this is actually going to cause a really big problem in terms of research. And that's because if nature is fractal, the data that we get is also going to be fractal. So our statistics will also change with changes in resolution. So let's say, okay, this is the stock market. Let's say we see this curve in a research set and we won't say, okay, let's, say that's a linear relationship. Let's try and draw a straight line. And then we measure the slope of that line. But if we zoom in to another section, let's say a smaller section, a smaller window, all of a sudden the slope is going to change. So our statistics are now not very reliable. They're going to change each time we zoom in and out. If we look at different reference points, our regular conventional statistics are just going to change. And some of you guys might have heard of the reproducibility paradox. And that is the idea that it's really difficult to reproduce any research. It's almost impossible, actually. And that is, I think, because if we're using conventional statistics to measure fractal data, then every time our resolution changes, our point of reference changes, we're going to get different results, which means we're not going to be able to reproduce things in different studies. So as Einstein would say, it's all relative. So we really need to think about this in a completely new way. And the take-home message here really is that traditional measurements change with changes in frame of reference, or zoom. And that really means that traditional statistics applying to a fractal system is really not possible. It's not as useful. It just can give us an average, but it can't really give us any kind of real information about the fractal system. And the next one is emergent complexity, or emergence, which is absolutely #1, my favorite property of fractals. And what it means is that from a very simple pattern, you get something that's very complex, something that you would never predict would be possible from that simple pattern. So it's almost like something magical happens. So like we were saying before, the z² + c, it's so simple. It's such a simple equation. And from that, you get the Mandelbrot set, which is this infinitely complex, very beautiful mathematical fractal. We can apply this to nature as well. So if we have a single molecule of water, it doesn't have any properties of wetness. It's just, a single molecule of water. But if we have more molecules of water, and even more, this emergent property comes out. So it's an emergent property of water, is wetness, sorry. A fertilized egg has its own properties, but out of a fertilized egg emerges an entire human body. And from a single neuron emerges intelligence, right? Billions of neurons making the brain, and out of which comes intelligence. And this, of course, is Benoit Mandelbrot. All right, and this is just a little animation here, and you can see this repeated pattern. As it, starts coming more and more and more, things start to look more and more complex and more complex and more complex. It's just simple circles, and all of a sudden things are just getting more and more complex. So the take-home message about emergence is that simple forms complex. Simple cell division forms the human body. And it really means that you're more than the sum of your parts, which is really, really important to understand. And the next property we're going to talk about is chaos. Now, I think a lot of you guys might have heard of chaos theory before. So we're going to talk about what that is. Fractals have logarithmic qualities or exponential qualities. And what that means is, as it's getting smaller and smaller, it's by several orders of magnitude. All right, and that means that fractal systems are really, really sensitive to changes in the system. If you change one tiny little thing, you could have massive shifts in a system. So for example, this is a picture of the Mandelbrot set, so just a still image. And let's say we changed from C1 to C2, we might get a completely different still image pattern. Because if we change one little parameter, because of this logarithmic quality, you're going to get something totally different. And this is where the butterfly effect comes from. I think many of you must know what this is. So a butterfly flapping its wings, creates a little bit of air turbulence, and that gets larger and larger and larger, and creating a hurricane on the other side of the globe. So that's what the butterfly effect is. And the take-home message here is, in a fractal system, small changes that are repeated over time can create a massive impact. And the final property we're going to talk about fractals is they actually have discrete properties as well as infinite properties. So this is the Coke snowflake. It starts with a triangle, and then you keep adding more and more triangles to the side. we can see here that if here's the iteration 1, 2, 3, the line is actually getting longer and longer. And so the perimeter is actually infinitely long, potentially. If you keep zooming in, you'll be able to measure more and more and more. And so the length of the line, of the outline of this curve, is actually infinity. But it actually has a discrete area, of course, because we can draw a circle around it, and it's always going to fit inside this circle. And this is this was really difficult for me to understand at first. How can it have this dual property? But we can apply this to things that are actually in nature. So this is Baffin Island. And Baffin Island, if we try to measure how long the coastline is, let's say if we use a map, we might get a certain answer. But if we use a satellite image, there's a lot more detail, right? So there's more nooks and crannies, and the line is actually going to end up being longer. So it actually is the same as the other mathematical curve that we were talking about, that the perimeter is infinite, but of course the area is just discrete. We have Baffin Island is always in one spot, it's in one spot on the globe, and it's always in the same spot. And our body is like this as well, right? Like I'm sitting right here, I'm a singular person, but my body also has these infinite properties. And so fractal systems can potentially have this dual quality of having both discrete and infinite properties, which is extremely abstract thing to think about. But some of you guys might be familiar with the wave-particle duality, which is that electrons in some experiments act as waves and in some experiments act as particles. And so this has always stumped physicists. They're thinking, why? How does it switch into a wave and then switch into a particle? But if electrons are fractal, it might be that fractals are key to solving some of the biggest paradoxes in science. So this information is really, really revolutionary. And so, some of that might be a little bit abstract. So how do we start applying this fractal wisdom to our health and healing? Because this is really the most important part. We have 9 principles of fractal wisdom that I'm going to share with you today. And the first principle is how to apply fractal wisdom to genes. So if you guys remember the Mandelbrot set, right? The algorithm is z squared plus c, and that's what governs that entire mathematical fractal. But what about you? What's your fractal algorithm? Well, your fractal algorithm is your genes. That's the code that generates your entire body. It's a very simple alphabet, and out of this very simple alphabet generates your whole body. And this is why personalized genetic testing is such a revolutionary concept. And for you guys, you probably know Nutrients is a great company that's working on this problem to provide personalized supplementation for somebody's personal genetic code, which I think is really revolutionary. All right, so how do we apply fractal wisdom to our bodies? Well, our bodies do have, on some level, this infinite potential. Our bodies are a fractal system. And this is actually something that's been helping me crush my limiting beliefs, because I used to tell myself, I'm never going to get better. Certain aspects of my health I could never fix. And then, once I started realizing this about fractals, I think there's a lot of things we don't understand. And so to realize that the body is so much more complex than we really understand, at least for me, it's very helpful for crushing those limiting beliefs. And as well with patients, fears about not being able to help them. What if I miss something? But I think it's helpful in that aspect as well. We can apply fractal wisdom to understanding the brain as well. If we look at the brain, this is a tissue slide. It really looks messy. It looks kind of random, but it's really based on a repeated fractal algorithm as well. And there's a new theory that's come out called the fractal brain theory, which actually states that perhaps the brain's algorithm is as simple as a binary branching algorithm, a fractal algorithm. So this really complex system, people used to always say, that we can never understand the brain, but really the algorithm is most likely much more simpler than we ever imagined. All right, so let's start applying fractal wisdom to our system of diagnosis now. So diagnosis is really the cornerstone of medicine. The whole point when you see a patient is to give them a diagnosis. That's the whole point of doing the lab test and the exam and the history. And I'm just using the example of the DSM because I'm a psychiatry resident, but you can apply this to other diseases as well. Excuse me. And diseases are really based on averages, right? Which really don't work in a fractal system. You know, depression on the surface might look like one thing, but we all know that everyone's depression is, you know, completely different. Everyone has different genes. Everyone had a different upbringing and experiences. So one depression is not like any other depression. It's very heterogeneous, and yet we're just treating it all as one uniform thing for some reason. Each depression is as unique as a fingerprint. And so this one-size-fits-all treatment approach it really doesn't work anymore in a fractal system. So our system of diagnosis is now really seeming like it's not very scientific anymore if we really consider the fractal nature of the body. And we can even start applying fractal wisdom to our data. In actuality, the noise is the real signal. So what in the EEG, when everyone thought that this was all the noisy data, this is actually the fractal signal. And now they're starting to apply fractal analysis to EEGs, and maybe we're going to learn something a lot more than just being able to diagnose strokes from this technology. And there's also this new era that's coming of fractal statistics, which is really just in its infancy still. So I don't have too much information about it. But if you have a data set, for example, is this random or is it fractal? And how would you know? Well, you can analyze it by taking the logarithm. This is not important really for you to memorize, but if you take the logarithm of both sides and the slope ends up being 0, it's what's called a fractal dimension. And that's how we know if the system is actually fractal. And the fractal dimension is actually really cool because we can use it to sort of guess the shape of a fractal. So if it's between 1 and 2, what it really means is it's not entirely the first dimension, which is a straight line, and it's not entirely the second dimension, which is a flat plane. It's in between the first dimension and the second dimension, and this is the Sierpinski triangle. And where you see the cutouts, that's essentially a vacuum. The fractal is never going to go in those spaces. So the fractal dimension of the Mandelbrot, I have to change that, sorry, that should be 2.2, or between 2 and 3, which basically means it's in between the second and the third dimension. So it's not entirely a cube, it's not entirely a flat plane, it is somewhere in between that. And that might sound really abstract, but what it really does is it helps us understand how things really can not tangle up in our body. We have kilometers and kilometers and kilometers of DNA, and it never tangles. How does that happen? Well, it occupies this very interesting space that's sort of in between dimensions, and that's what lets things to keep functioning normally. We can even apply our fractal wisdom to research. So traditionally, the RCT, you know, is the gold standard, the randomized trial, where you take the treatment group and the control group, which gets the placebo, and then you compare the two together, the averages of both groups. But we already know we can't just take averages and compare them, because each individual person is its own fractal system that's as complex as the universe. So this, you know, this gold standard approach really is starting to seem less scientific as well. And so what's a new way that we can start to understand? We need another way to do clinical trials, really. And we can take a lesson from the Big Bang Theory. There was an episode where they essentially, Sheldon and Leonard were trying to figure out where to go to the movies. And so they started doing this charting system here, which is called graph theory and network theory. And so instead of creating two averages and comparing them, what you do is you kind of retain all the data on one chart. And you end up getting these clusters. And this data actually retains all fractal properties. And the beauty of it is you can start seeing, oh, maybe these people got better because of this one doctor they were working with, or maybe these people got better because of some genetic quality that they have. So you can start to see clusters of individuals and really start personalizing things and interpreting the data in a relevant way that can help more people. And so what about the placebo effect? You know, we've been taught we need this placebo effect because how do we know if the treatment really works? Is it all in your head? But really, you know, subtracting the placebo effect is a statistical exercise in a giant population of people. And we don't remove our brains when we go see our doctors. So, you know, we don't need to worry about that so much. That information is still going to be present when you do network theory or graph theory. So our gold standard is now not seeming so much gold standard, which is really disappointing. But what's interesting is our single blind studies are actually a little bit more strong because we don't really need to do this randomization. So if there's a study where people are really, you know, improving, but it's not necessarily randomized, you know, there's still a lot of really useful information there. And the case study, more than anything, becomes the new gold standard because personalized medicine is really the future. Each individual person is as complex, you know, is almost infinitely complex. And so we really need to start understanding the utility of this personalized approach. And what's really good about this is it's going to help us reduce our dependence on pharmaceutical money because we don't need to have necessarily these giant large-scale trials to do this randomization because the randomization is not really needed anymore. We can apply fractal wisdom also to the concept of time. So fractal systems are recursive, and what that means is what happens at the beginning kind of impacts what happens later. So what happens at the start of your life really has the biggest impact. And we already know this because early childhood trauma is the biggest risk factor for chronic illness. There was a Kaiser Permanente study called the ACE study that showed this. And so, you know, this is a really important factor to consider when you're working with your clients, especially if they're not getting better from, you know, the basic treatments. And nothing that happens in your life is a coincidence. So is this familiar to you? You know, let's say you ate something and then all of a sudden you started throwing up. You go to your doctor and they say, well, you know, how can you know that it was related to what you ate? You know, that could just be a coincidence. And I mean, it's true. It could have been something you ate a little bit before, but everything you do affects the system of your body because that's how fractal systems really work. But of course, we have a counterbalancing mechanism of homeostasis. So not everything that happens to us is going to cause things to shift so wildly. But that's just really something to think about. So if there was a major event that happened in someone's life, you know, that's definitely going to impact their health. There's no doubt about that. So a person's story is really, really integral to functional medicine because it's going to help you understand what might be the trigger points that caused a person to become sick. And it's not just a story anymore. It's actually becoming science. In terms of time, also, the more proximal we treat, the more impact we can have. So we have to treat the cause, not the disease. So we can either, you know, somebody comes in, they're having heartburn, they can either change their diet or, you know, we can give them a proton pump inhibitor, right? Which one is more effective? It's obviously more effective to change the diet, to treat the cause. Because of this interaction between epigenetic and genetic factors, we really can have a massive impact if we focus more on treating the cause. So let's try and apply some fractal wisdom to a clinical situation. So what we want to do in functional medicine is really help people make a lot of lifestyle changes. And because of chaos theory, small, consistent changes are key to making massive impact. So all you need is a small amount of medicine and you can completely change how the body is functioning. You know, small amounts of drugs can completely change within seconds, a person's behavior. And losing 5% of weight has also been shown to have massive health benefits. When I learned this in medical school, I didn't even believe it. I thought that was complete BS. But if you think about it from a fractal perspective, it makes complete sense. If you change something small, the system is going to still drastically change. And even more so, I learned about this in medical school, no smoking for 24 hours. And your risk of heart attack goes down by over 50%, even if you're an elderly person. And so even if somebody's older and been smoking for 40 years, it's still going to have a health impact to help them quit smoking. So, and it really is from this fractal property. So if you change one thing, just one thing, and if you repeat that and if you're consistent with that, you can really have amazing benefits. And this is really helpful from a motivational aspect, right? Because sometimes it's a little overwhelming. We think, oh my God, I have to change all of these things, or I have to change everything in my life, and then people give up. So this can, if you keep this concept in the back of your mind, you can kind of use it to help motivate your clients to just focus on one thing, focus on a smaller goal, and be consistent, more importantly. So now, probably the most important thing is, how do we apply this fractal wisdom to functional medicine? And what's really the connection there? This is what I brought up at the beginning of the talk. It's what got me into functional medicine for myself. And so, the conventional approach is really thinking about it in a too complicated way. Too many diseases, each disease has to be studied separately, rare diseases get totally left out. So this is just way too complicated, and it's not useful, it's not helpful. But really, this complex fractal universe that we live in is based on super simple algorithms. It really is. And what this means is that complex problems actually have simple solutions. So that's why functional medicine is so, so powerful, right? Here we have the functional medicine matrix, which all of you guys are familiar with. And it's any health issue can be completely simplified from this approach when you start looking at the basic body systems and how they're all working together. So it really just takes all of that complicated taxonomy from our diagnostic system and simplifies it to root cause approach. And what's really brilliant about the functional medicine matrix is that everything that's happened in a person's life is on this chart, right? Which is essentially like doing network and graph theory without doing a single bit of math. So you're already doing fractal math without even knowing it, which is really amazing. I think that's why functional medicine is so powerful. So if we focus on basic principles, we can get simple solutions. And that doesn't necessarily mean that they're easy to do, because changing your behavior is not easy at all. But it's a lot more simple than having to study each disease individually. So this simplifies things for us. I love the functional medicine matrix. I think it's so great. And it helps you think about the body in a way where you really start thinking, okay, well, how does the body work? Why is this person's body not working normally? And how do we help them make it function more normally through diet, through lifestyle, through meditation, through all these different things, through optimizing their nutrition. And for me, it's actually helped me reduce my clinician anxiety, because I would always worry, like, what if there was some small thing that I've never learned that I missed, or something like that, or what if it's a misdiagnosis? But if you really focus on basic principles, you can have massive impacts with even small changes. If applying this fractal wisdom. So, being calm, staying consistent with your clients, all the work that you guys are doing is really, really, it's helping so many people. And I think that, it's fantastic. Functional medicine is really in its infancy, but I really think that this is one of the most amazing things, because it's essentially fractal medicine. And so this is why I think functional medicine is superior, because functional medicine, in my eyes, has fractal qualities, and the universe, of course, does as well. And this is actually being shown in research too. You know, the MEN protocol with Dr. Bredesen is showing that this type of approach is able to completely reverse the diagnosis of Alzheimer's, which is, you know, it's amazing. It's such a devastating condition. So maybe the chronic disease epidemic is about to end, hopefully, and that would be great. And we have one last bonus. I have a bonus principle for you guys about fractals. And this bonus principle doesn't have anything to do with health, but I wanted to share it with you guys anyway, because I find it fascinating. So fractal wisdom also has something to say about spirituality. Normally, our conventional view is that we have on one side this scientific wisdom, and on the other side, we have, you know, spiritual wisdom or religion. And, you know, they don't really kind of go together. One is on one side, one is on the other side. And what's the fractal view on this? Well, some of you guys might have heard of the phrase, as is the macrocosm, so is the microcosm. And this is a piece of spiritual wisdom that's found pretty much in every single religion. Every single religious text pretty much has this. As above, so below is from the Emerald Tablets, ancient Greek. On earth as it is in heaven from the Bible. The Dalai Lama has written a book called The Universe in a Single Atom, The Convergence of Science and Spirituality. And as is the human body, so is the cosmic body. That's from the Upanishads in Hinduism. As is the human mind, so is the cosmic mind. And what these phrases really mean is that patterns in the universe reflect patterns on Earth, you know, which is essentially describing fractal self-similarity, which I think is really fascinating. So many of you guys some people might have seen this, but this is a neuron on this side, a fluorescently stained neuron. And I had shown this before. This is a distribution of dark matter in the universe. So somehow, you know, ancient religions seem to have this knowledge about the universe, about patterns repeating. And fractals, you know, are kind of merging the ideas of science and spiritual wisdom together. So it really is a very, very fascinating field, and it can really add a lot to what we understand about science, the universe, our health, ourselves. So I hope that you'll help me welcome this new era of fractals. And so, you know, we went through all of the objectives, and we have our post-test here. So, you know, we said this was linear before, but of course this is fractal. And here we have the binomial distribution. As we increase the trials, it's still going to be stepwise. Even if the steps are so tiny, it's still going to be stepwise. It's never going to become continuous. And so this is, of course, also fractal. And I just wanted to remind you guys of the law of the instrument, which is if all you have is a hammer, everything looks like a nail. And so if we use the wrong tools, we're going to get the wrong answers in science. And so fractals really are that new tool. And we need to start thinking about things not in a simplified way, but in a fractal way. We need to embrace this roughness and complexity for this new era of science and medicine. So conventional medicine really needs to embrace both functional medicine and fractals. I strongly believe this. But there's a problem with this, and that's there's a lot of criticism of functional medicine happening right now from critic blogs like Quackwatch, Science-Based Medicine. And when you try to look up functional medicine, there's some of the, like it's basically the third thing that comes up is an article that's just completely bashing it because there's not enough randomized controlled trials, essentially. You know, they say that there's no RCT proof, you know, but the real proof is fractal, as I hope that I've been able to show you in this talk. And so this information really needs to spread. We really need to start using the right tools in order for our patients to really get better. And so, yeah, I just encourage you guys to share this talk, share this information. I'm working on a book to get this message out there. Hopefully it'll come out next year, definitely. Just kind of balancing my health as well. And you can connect with me, info@fractalformula.com. If you have any questions about fractals, if anything was confusing, please send me an email or send me a message on Facebook. I'd be happy to answer any of your questions, any and all of your questions. So, yeah. I'd like to say thanks again to Sachin. I hope this talk was, was a lot in there, and I didn't know if I should take some stuff out, but I really hope that, that it was useful, valuable information for you guys.
Well, I certainly find this very, very fascinating, and I know that your book is going to really, turn this paradigm that we have right now upside down. And it's nice when, you can use math to prove something, because it, in a sense, becomes irrefutable. You said a few things that I wanted to highlight, kind of in the personal development space, right? Which is how you do one thing is how you do everything. So, that's kind of a fractal, formula, if you will. And small things done consistently can lead to massive things over time. So if you're somebody who's trying to recapture their health or regenerate their health, or just, feel better, then you don't have to change everything. Change one thing. And if you do that consistently over time, you're going to see some, staggering, benefits. And the same thing goes for bad things, right? Some people might think, well, I just do a few bad things a day. Well, that adds up over time as well. So be very hyper conscious of your thoughts, of your actions, of your behaviors, because over time it adds up. And here's the thing: wherever you are right now in life is a result of all the good things you've done, small good things you've done, and all the bad things you've done over a period of time. But the cool thing is that you can change that instantly by using and applying this knowledge and understanding the implications of it. One thing that I also wanted to comment on is that, as we saw, there's basically infinite surface area in some of these structures. And really, if we apply this this understanding, infinite surface area means infinite data storage capacity. And so your body literally has infinite data storage capacity. So, this is where, and I don't want to get too far off here, but this is where, past lives and things like that can come into play. I mean, there's mathematical evidence that we have the ability to store in our cells information that has happened, thousands and thousands of years ago. And with the self-similarity and replication that takes place as each generation is born, that information set gets transferred as well. And now we have the instruments. We didn't even have computers to be able to do this. And then we had somebody smart enough to try to, accidentally essentially solve this problem. And it's going to take some time until conventional medicine accepts this, right? But it starts with pioneers, Sab, like yourself, who are, willing to stick their necks out there and educate people in a mathematical system that we have little to no training in. But, once you open your eyes, it's evident, it's everywhere, and it's at every single scale of the universe. And, I was once, connected with a spiritual mentor, and he told me that, everything you need to know about the entire universe is in this blade of grass. And he had this little blade of grass in his hand. And I didn't get it at the time, but now it makes total sense, right? Because everything you need to know isn't, you don't have to know everything. You just have to know one thing, because it's all, written by the same hand, if you will. So this has been, for me, super, super enlightening. If anyone has any questions, then I'm happy to answer any of them. So if you're on Facebook and you're joining us, then feel free to, post any questions that you have. But the feedback has been, very positive. I know you can't see it, but we have people, Melanie saying thank you. We have Diane saying brilliant. A question that came in from Irina is how about to learn and embrace our own body? Or how do we, I'm assuming she's asking, how do we learn about it and embrace our own body? Ruby is saying, thank you, Sab, for spreading the truth and knowledge. Robert is saying, amazing stuff, Sab. Thank you so much for sharing your knowledge. Michelle says, thank you, Dr. Virani. So yeah, tons of positive feedback. And, this is truly, truly fascinating. And I know that you and I both personally have an interest in mushrooms because of their amazing health properties. And, one of the things that I look at when I look at mushrooms, when I look at nature is, we have this medical system that's conditioned us to look at the hardware. So we're conditioned to look at the the micronutrients and the macronutrients, the carbs, the proteins, all that kind of stuff. But when we look at food as math, which is essentially software for our body, then it becomes very clear why, plants and herbs and mushrooms and things like fungi, things like that can be so powerful, because it's a fractal plugging into another fractal. Exactly. And so I don't know if you had any commentary on that as well.
Well, I think at Perfect Practice, you had showed that image of, the fungus, right, also has a branch structure, just like the brain. These patterns can plug into each other. Our bodies are designed to work with the rest of nature. So I think natural things have a very powerful impact on our body. And it's good to see now that there's a lot more investigation coming and a lot more interest in even conventional medicine. I think psilocybin, which is, I guess, magic mushrooms, is now being studied for, I think, maybe PTSD or depression, but there's an FDA clinical trial first arm that's just starting. So the conversation is shifting. And I just wanted to share as well, I put together a fractal deep dive for everyone, which I'm going to put into a Google Doc, and I'll share it in the group. But essentially it's some books that are geared towards, one of them is a free textbook that you can find online, but it's all geared towards, medical sciences or biological sciences. So this is not like super math heavy. And there's a lot of videos here as well. Videos by Dr. Robert Sapolsky, who's a Stanford biologist. There's some animated videos in there. So if anybody wants to kind of go into a deeper dive with fractals, I put this together for you guys. And I'll post that in the group as well.
Yeah, and just to give your book a little bit of a shout out, I read it. I couldn't put it down. So if anyone knows me personally, you would know that I read a ton of content. I listen to a lot of content, but I do it in spurts. But your book I picked up and I read through and through. So if that says anything, it was definitely it was definitely very, very well written and easy to understand. I know today you went a little bit deeper into some of the math, but the book is excellent. So I'm looking forward to that release date. I can't tell you how proud I am of you, and for really stepping into this message and believing in it. Because this is really going to change a lot of lives. I mean, it's going to change billions of lives. And this is just the start, right? This is just that little small step that we're taking together to really shift, hopefully the future of humanity. So if all of you who are listening can do us a huge favor and just share this, just copy the text that I've posted and share this, then that little action is going to help create the butterfly effect that we're trying to create, educate more people, create more awareness so that people can start getting healthy. And one of the things that I would probably argue is that I bet that IFM doesn't even realize this. I don't know if you've contacted them yet, but they probably don't.
Because I have this talk with them, hopefully,
Yeah, so they probably don't even realize that they're sitting on this mathematical gold mine. Yes. Because one of the challenges of functional medicine, and this is something that I've talked about for quite some time, I just didn't have the math to prove it, is that we can't prove functional medicine, which is a fractal medicine, in kind of a, I don't know if Newtonian is the right word, but in kind of an archaic mathematical model that is really not designed for our bodies and for nature. And this is why our medical system has failed us, over and over again. It's not because they're not trying. It's not because of bad people. It's not because, we haven't spent enough money. It's because we've been using the complete wrong paradigm to solve this problem. So now we know what the problem is, right? It's not greed. It's not evil people. I mean, maybe there is some of that, but really it's the math. And so this really demonstrates the power of the math, the power of fractals, and the power of pairing fractals, especially when it comes to your own personal health. And it demonstrates firsthand why a food item, a natural food or a wild food, an herb, a plant is going to work infinitely better than a drug would work, which has isolated, fragments of a plant or, a fungi or whatever the case may be. So there's really no, drugs are no match for what nature's capabilities are. And now we have the math to prove it. So thank you for being that beacon of light and sharing this with us. And is there anything that you can close with that could inspire us to take maybe some small actions so that we can create that butterfly effect in our own personal journeys?
Well, I think you summed everything up. People need to, I can't remember who said this, but it's not what you don't know that's dangerous. It's what you don't know that you don't know. And this is what medicine doesn't know that it doesn't know, So the ignorance of this whole idea about fractal math and the fact that we're using the wrong math, this message really needs to get out there. So small changes, big impact, just share this message with as many people as you can. I would be so grateful. And I think it's really, really going to help change the entire system. So thank you so much for this opportunity, Sachin. I really appreciate all your encouragement with everything. You've been my mentor, and I can't thank you enough.
Well, thank you once again. And you have yourself an amazing sleep. It was very, very well deserved. Sweet dreams to you, and sweet dreams to everyone who had a chance to join us. As I said, the only favor that we're going to ask of you is to share this so that we can get this in front of as many people as possible. And you never know who watches it, who sees it, and what interest it sparks and what changes it might spark. So I hope all of you can be part of that amazing butterfly effect that we know is going to take place. And this is your chance to be part of it. So good night, everyone. Thank you. And I love you, and have an amazing night.
All right. Good night.